Hi, and welcome back to this introduction to dApp development. In the first two episodes, we discussed some basic dApp concepts and the architecture of a dApp. And in the previous episode, the third episode, we set up a basic Hello World Next.js project. In this lesson, we're going to discuss wallets in more detail and integrate the Beacon SDK into our dApp to allow users to connect their wallet and sign a payload. Okay, so let's look at the structure of this episode in a little bit more detail. So first of all, we're going to learn what a Tezos account is. Then we're going to learn what a wallet is. Then we're going to look at some different types of wallet. And then we'll move on to the implementation side of things. So we'll open up VS Code and we'll see how to connect to a wallet using the Beacon SDK. And then I'll do a brief aside talking about GhostNet. And then finally, we will make our dApp request our wallet to sign a payload for us. Okay, so hopefully you recognize this slide from episode 2 where we talked about the architecture of a dApp. I just wanted to bring this up just so that we can remember whereabouts in the whole architecture of a dApp we're currently focusing. So you'll see here episode 4 wallets. We spoke about wallets, and just for your reference, we are focusing on this part of the dApp architecture today. Okay, so before we get to wallets, we need to discuss what a Tezos account is. An account at its most basic is just a private key. And from this private key, we can generate a public key and a Tezos address. In terms of real-world analogies, you can think of an account a little bit like a bank account. So your private key would be a little bit like your PIN number or your signature that you might sign checks with. And your Tezos address is a little bit like your bank account number, which you might give to someone else if you wanted them to transfer you funds. There isn't necessarily a good analogy for the public key, but if you think of the private key like your PIN number and your Tezos address as your bank account number, then hopefully that will help explain things a bit. So the private key is used to sign messages. And the private key, I'll repeat this probably multiple times through this course, should not be shared. The public key is used to verify ownership of a private key. So if you've used your private key to sign a certain message, i.e. to put the message into a form that is encrypted but provable that it is owned by you, the public key is the thing that can prove that that message was signed by you, i.e. your account. So 2 things to note. Number 1, I will probably say this multiple times again through this course, do not share your private key. If you share your private key, that's a little bit like sharing the PIN number on a bank account. It means that someone could access your funds. And the second thing is a small technical note, which I've said at the bottom, which I think is a useful concept to understand as a dApp developer, is that your Tezos account doesn't hold cryptocurrency or hold tokens in any kind of physical way. There isn't your account that exists somewhere on the blockchain and within it is cryptocurrency or tokens or anything like that. What actually happens is on the blockchain ledger or within the storage of smart contracts, a certain token will be associated with your Tezos address. So actually the ownership of entities on the blockchain doesn't sit within your account. It sits on the blockchain, and all that your account is this private key that basically says, I am the owner of that account. It doesn't hold anything. And to refer back to the first bullet point on this slide, a Tezos account is essentially just a private key. So now we understand what accounts are, we can move on to wallets. And the concept of accounts and wallets is sometimes sort of merged between some people in terms of in normal language when people are talking about blockchains and dApps. Sometimes they use the term wallet when they really mean account. But I think it's definitely useful to understand the differentiation between the two. So wallets are applications that allow you to manage one or more accounts. As I said in one of the earlier episodes, in general, we're just going to think about our wallet only having one account because it can save some of the confusion. But it's useful to understand that wallets are applications that allow you to manage multiple accounts. Wallets are often have a seed phrase associated with them. So when you're creating a wallet, you'll be provided with a seed phrase, which is just a list of 24 words or 32 words or something like that. And you can think of it like a password to the wallet. So similarly to the fact that you shouldn't share the private key to your account, you also shouldn't share the seed phrase to your wallet, because if you share the seed phrase to your wallet, someone could use that to access your wallet, and then they'll have full access to your accounts, and then they can drain your funds. And there have been many horror stories in the press about people having a wallet, losing their seed phrase, and not being able to access millions of dollars worth of cryptocurrency or something like that. So onto the different types of wallets. So there's broadly 4 different categories of wallets, and some of these you may have come across and some of them you may not. So the first type that we have here is web apps, and an example of a wallet provider on Tezos that is a web app is Kukai. And these are usually custodial wallets, which means that they're semi-managed and that the private key isn't necessarily completely managed by the user. The application does some of the management for you. It can add a little bit of a safety net. And then the next type is hardware wallets, and an example is Ledger. Hardware wallets look a little bit like a USB key, and the private key is held within the wallet. And these are non-custodial. So it basically means that you have sole ownership and sole responsibility of the wallet. But they are incredibly secure because the private key isn't stored on any computer or any program or anything like that. So someone would literally need to physically obtain the device from yourself to gain access. So people with high value accounts will often manage them through a hardware wallet and store that hardware wallet in a safe or even at a bank for high security. And then the other 2 broad categories of wallets are browser extensions. So MetaMask is quite a famous one. Temple Wallet is another very popular one within the Tezos ecosystem. They're non-custodial, and the private key is stored within your browser. So if someone got access to your browser, then they would have access to your account. And then the final one is applications that may be desktop applications or something like that. An Umami Desktop is an example of a application or desktop application wallet in the Tezos ecosystem. Again, non-custodial, and the private keys are stored locally within the app's local storage. Okay, so now that we understand the difference between an account and a wallet, let's talk about the Beacon SDK. Now, we've mentioned the Beacon SDK before, but just to remember, it's an SDK that allows dApp developers on Tezos to easily integrate wallets into their dApps. There's a few more details on this slide. I'm not going to go into too much detail about them, but they're here for reference. But the one important thing at the bottom is that Beacon integrates very well with Taquito, which is a different library that we've spoken about before. And if you look at the documentation on the link in this slide, which we will be following later in this episode, you'll see that there's kind of 2 different flows that you can use when you're integrating with Beacon. One of them is the sort of pure Beacon flow, and one of them is the Beacon flow with Taquito, and we're going to be following that Taquito flow. Also, as a small reference point, this slide gives a little bit of an overview of how the dApp and Taquito are able to establish a secure connection within each other using something called a matrix network. The details aren't particularly important, but if you're interested, you can look a little bit more into matrix networks to understand how they establish this secure connection. Okay, So quickly before we start coding, I'm just going to show you that I'm going to be using a Temple wallet for the rest of this course. So the Temple wallet you can see here is a browser extension. So if I click on it, you'll see my wallet. And here is the Tezos address associated with this wallet. You can see that currently it doesn't have any value in it, any Tez, but we will add some Tez, some cryptocurrency to it later because we need that to do certain operations while we're testing our dApp. But yes, so this is just to, if you've decided not to use Temple, you've decided to use a different wallet provider, that's totally fine. But just so that you understand, this little browser extension is my Tezos wallet. And the account that I will be using, because this Tezos wallet is managing multiple accounts, but the account that it's using is this one here, ending 6M. Okay, so here we are back in VS Code, and it's in the state that we left it after episode 3. So let's just check that our dApp is, or our app, because it wasn't actually a dApp yet, is as we left it. So I'm going to run npm run dev, just to check that when I go to localhost port 3000, that it's still appearing as we were hoping. So yeah, there we go. Saying hello world. Perfect. Now, the first thing that I'm going to do, just to structure this code so that we can see all of the separate episodes and refer back to them later, is I'm just going to add a new directory here called, let's say, episode 3. And then I'm going to move this page in there. So now we will always have a copy of that, and now I'll make a new directory called episode 4, and I'm going to copy the episode 3 code into there so we can start editing it, but we'll still have a copy of the episode 3 code and so on in the later episodes to refer back to. So just to check that that's all worked correctly, I'm going to go back here, and now hopefully at episode 3, yeah, we can still get to this application on episode 3 and at episode 4 as well, but we will start now editing episode 4. Okay, so the first thing that we said that we were going to do was we were going to use Beacon to connect a wallet. So I'm going to jump over to the Beacon documentation. And here we are in the Beacon documentation in the Getting Started section, my first dApp actually specifically. And we're using the Taquito tab of the Beacon documentation as we talked about in one of the previous slides. So the first thing that we're going to do is we're going to install these 2 dependencies. So let me stop the app from running there and paste this in and install those 2 dependencies. Meanwhile, I'm going to go over and have another look at the documentation. The first thing that we're going to do is import the Tezos toolkit and the Beacon wallet from the 2 libraries that we just installed. So that should be easy enough. Do that like that. And then I'm going to copy and paste these 3 lines as well. And what these 3 lines do is they initialize the Tezos toolkit, which is like initializing Taquito. And the parameter that you will see here, this is the address of an RPC node. We talked about RPC nodes in episode 2, and we'll talk about them again later in the course. We will also talk about how to change this parameter to the address of a different RPC node. It doesn't matter really what it is. You just want to find one that works. And this one, I assume, will work because it's in the Beacon documentation. If it doesn't, we'll find another one. And this parameter here, we don't need to worry about it too much. So I'm just going to copy and paste these 3 lines into the top of our file. So that will initialize Beacon. Okay, so what do we need to do next? The next thing we need to do is get some React state that we can use to store our wallet address. So const wallet address, set wallet, address, equals use state, which requires a React import. That's just auto imported for me. String or undefined. So that means when our app loads, by default, the wallet address will be set to null or undefined specifically. So the next thing that we need to do is actually add some functionality to get that wallet address. So this is our first bit of code that will actually turn our app into a dApp. So let's start. We'll call our method connect, or our function connect, and it's an asynchronous function. And so this is the important part of the code. So we're going to get the permissions associated with our account by using Beacon. So we're going to set to permissions equals wait wallet.client request permissions. There we go. And if we simply log out those permissions, then we'll be able to see what this permissions object really is. So what I'm going to do actually is I'm going to now, from our Hello World app, it's got all of this stuff, boilerplate stuff that Next.js gave us. We can just delete all of it because we don't need any of this for now. And I'm also going to delete all of this because we don't really need that. I'm going to change Hello World to, let's say, episode 4, just so we've got a nice reference. And then in here, I'm going to create a button. Let's see, and its onClick method is going to be this connect that we just wrote above. And let's call it connect because then it's easy to read. So I'm just going to tidy this up a little bit. Okay, so now if I run my application again, so I'm running npm run dev again in the terminal, the bottom. Hopefully, when we click connect, it will call this connect function, and it will log out the permissions object that we get when we call wallet.client.request permissions. So that's basically saying to Beacon, can I have the permissions of the user's wallet? So let's try that now. I'm going to open up the console at the bottom so we can see what's logged out. And let's give it a go. Okay, so that didn't work. Maybe. Okay. So the reason that didn't work was because I hadn't marked this file as a client. This is a Next.js specific thing that I needed to do. So apologies for that. Okay, so let's go over to the dApp. I'm just going to refresh it. So we've got our connect button here on the right, and I'm going to open up the terminal so that we can see what's logged in the output. So first of all, I hit connect, and here we go. We have the Beacon modal showing up, which is excellent. I'm going to click Temple because I'm using a Temple wallet for this. I can click connect now, and here we go. It's opened up. It's given me the ability to choose which account I want to connect with. So I'm going to connect with this bottom account, and I'm going to click connect. And I have clicked connect, and it says that Temple Tezos has given us permission. And you can see here at the bottom that it has logged out the permissions object that we hoped that it would log out. So what do we want to do with that? Well, we can see that in the permissions, well, we could see if I opened up in the permissions object that it has the, where are we, address. And that is the address of my wallet. So now we have given our dApp access to the address of my, sorry, not my wallet, my account. We've given the dApp access to the address of my account, which is an incredibly useful start. So what I'm going to do is, instead of logging out the permissions, I'm going to go set wallet address permissions.address. So there we go. Now we are saving our wallet address within our React state. So we're looking pretty good. Let's go back to the documentation, wherever that is. Here it is. Okay, right. So what's the next thing that we want to do? There is a section here in the Beacon documentation that basically explains that the code that we've put in so far is great, and it allows us to connect our wallet, but we don't need to necessarily run it every time we start our dApp, because it could be that the user had previously connected their wallet and has maybe moved off the tab, come back to the tab, and they're still connected, so we don't need to actually force them to connect again. Their connection has persisted. So this code here explains what you need to do if you want to basically access a connection to Beacon that's already open. So I'm not going to do it exactly like this because, as you can see in this comment, it says the following code should always be run during page load. So this code isn't quite React specific. So I'm going to use React's use effect functionality to achieve basically this. So maybe it'll make a little bit more sense as I code it up. So I'm just going to add here use effect. Oh. Check account. So now this is using essentially this functionality here. So const Beacon active account equals await wallet dot client dot get active account. And then if such a thing exists, then set wallet address as Beacon. Oh, Beacon active account dot address. And then I need to check account. Need to call that, and then here. Yes, sorry, I need to import that as well. There we go. So this means that if we go to our dApp and we had recently connected to a wallet, the wallet address state of the React app will automatically get our account address. We won't need to specifically click the connect button to go through that flow. So the way that we can check whether this is all working is we can display the wallet address. We can say if the wallet address exists, then we can just show it. And if it doesn't exist, then we can force the user to connect. So connected with wallet address. Oops, sorry. Something like that. So now we'll go over to Chrome again, and we'll try localhost 3000/ep4, where we were before. And you can see I didn't even need to click connect this time because the code that we just added knew that I was already connected, and now it's displaying that we are indeed connected with the account address as we hoped for. So that is good stuff. So the next thing I'm going to do is I'm going to show how to disconnect, which is relatively easy as well. So I'll move back to here, and I'll go const disconnect equals async await wallet.client.clear active account, and then set wallet address as undefined. And then I can change this connected with wallet address to a button that says on click equals disconnect. And then I can say something like disconnect from wallet address. So now this button will have the connect button if we're not connected, i.e. if wallet address is undefined, and if wallet address is defined, it'll prompt us to disconnect from that wallet address. So let's have a look. Yeah, disconnect from that address. If I click it, it disconnects us. If I click it, it asks us to connect through Temple again, as we've already done. So now we have connecting and disconnecting from our wallet using Beacon, which is a pretty great stage to have got to. So the next thing that we're going to do is we're going to talk about how to sign a payload. Okay, so the final concept that we're going to introduce today is signing messages. We talked about this a little bit earlier, but in the world of dApps and blockchain, to prove that a message or a command came from a certain account, that account can sign that message using its private key. And the signed message, the fact that the message has been signed by the private key can be verified by someone else by using the account's public key. So you can think of signing a message a little bit like, maybe a king in the olden days putting their wax seal on a message. It not only protects the message so that you can't see exactly the contents of it, but it also proves that it is from that person, because only the king would have the certain wax seal or something like this. Okay, so let's look at a little graphic just explaining very simply what this process would look like. So the dApp would say to the wallet, please sign this message for the account TZ121, whatever. This TZ121 is just standing for a certain account address. And the contents of the message, we don't need to worry about them right now, but let's say that the dApp wants that message specifically signed. And then the wallet, because the wallet holds the private key of the account, can then sign that message and it can return it to the dApp. So it'll say, sure, the signature is, and it'll be some unreadable string of characters. So now we're going to see how that can be implemented in a dApp. There's many use cases for when we might want to do this. We won't actually go talk about those use cases right now. But also one thing to understand is that when you call an entry point on a smart contract, we'll get into smart contracts later, we discussed them a little bit earlier, but when you're essentially calling a function on a smart contract, you will implicitly be doing this. So you will be signing that the parameters and the contract call so that the smart contract knows that that it was a particular account that was calling that smart contract. And one final concept before we do the signing of the message is we're going to talk about GhostNet. Now, the reason that we're talking about this is to sign a message, we will need to pay something called a gas fee. And gas fees is a concept that basically when you're doing operations on the blockchain, it will cost you a certain amount of the native currency of that blockchain. The concept is called gas fees, and you can read up about gas fees. So while we're developing, we don't want to necessarily pay actual real money to do this because it can get quite costly. So instead of doing our development of our dApp on the real blockchain, which is often referred to as mainnet, we're instead going to use GhostNet, which is essentially identical to mainnet, but it's not the real one. It's a testing environment, and you can acquire TES on GhostNet for free. Basically, you don't have to actually pay dollars or pounds or euros or anything like that. So we'll be using GhostNet from now on. We can still use Temple in GhostNet mode. That's totally fine. But we're just going to switch over to GhostNet so that as you're testing this, you're not actually having to spend real money because that can get quite costly during development. So what we're going to do is we're going to go to a GhostNet foreset, which basically is something that we can click a couple of buttons and get 100 TES or 10 TES worth, which will be more than plenty for our development purposes. So I'm going to click on this link here. And you can see that it's already got my Tezos account linked. For you, maybe you might need to actually link it using Temple. And then I can literally just say I want 10 TES. And I can request 10 TES. And it'll give me 10 TES. Okay, so if I now open up my Temple wallet again and switch it from mainnet to GhostNet, you'll see that I now have 10 TES. Brilliant. Okay, so now let's move back over to VS Code. and let us sign a message. So we're going to need to refer to the documentation again. And actually, the better documentation for signing a message is on Taquito instead of on Beacon. I just think that the instructions are better and it includes some details which we're going to need. So if we go over to these Taquito docs, you can see at the top we have gone to the signing data area of the Taquito documentation. You can follow this through yourself. I don't think I need to go into all the details, but what is important is this section here. Okay, you need to make sure that you include this section. What this is basically doing is it is encoding the bytes of your message into a way that Tezos will understand. It's just boilerplate code. Once you've got it in your dApp once, you can use it a load of times, but you need to make sure that you don't forget this. Otherwise, Tezos will not understand the encoding of the message that you have done. So anyway, so I'm just going to basically import this chunk of code as just a helper function. So first of all, I will add this import statement, and I'm going to basically, in a slightly nicer form that I prepared earlier, include that code here. And this will just convert the message that I want to be signed into the right format, essentially, that Tezos understands it. As I say, this is just boilerplate code. You don't need to worry about the details at all. You just need to make sure that you have it. Okay, so let's go back over to the documentation, and this part here is what we're going to be using. So this, again, is kind of boilerplate code that essentially is formatting our inputs and everything like this so that we can eventually sign the payload. So the first thing that I'll need to do is I need to make sure I install this one dependency, which just has a couple of types that we need to use. So let me just go npm install, dev, this one, and then I can import this. Okay, so let's bring this code in now. So I'm going to add a new function called const sign equals async, and then the response I'm just going to rename this to response, and then the payload, I'm just going to include it directly as a parameter instead of passing it in separately, just because I prefer the formatting like that. And then the source address is going to be our wallet address, and the payload is going to be, what are we going to call it? Tezos signed message. Signing message for my first dApp for user wallet address, wallet address at, and then let's format the date. So we can say new date to isostring. Perfect. And the next thing that we need to do is we need to make sure that we wrap this payload in our helper function that we brought in earlier. Where is it? There we go. And then finally, we can log it out. So console.log response.signature. And then I'm just going to add a button. So let's do it in a similar format. If the wallet address, if we have a wallet address, then we can have a button on click equals sign message. If we're not signed in, then I'll just say not applicable for now. It's not the most beautiful UI that you've seen in the world, but hopefully it will do the job. There we go. Okay. So finally, we can test this. So just to reiterate what we've done, we first of all added this little helper function. It's just boilerplate. In all of your dApps that use Taquito, you will just have this same bit of boilerplate. You don't need to stress too much about it. And then we've essentially just pasted some code from the Taquito documentation that is converting this message here using the helper function that we had. And this will ask the wallet to sign this message, and then we're going to log out the signed message. And as I said earlier, we're not actually using this signed message for anything specific at the moment, but it's just a useful thing to learn and to understand because there are a lot of use cases where you might want a signed message. You can give this signed message to another dApp and or a smart contract or anything like that, and that smart contract will be able to verify using the account's public key that this message was signed by this user. Okay, so let's see if this runs. So I'm going to start the application again, npm run dev. I'm going to switch over to our dApp and I'm going to hit refresh. And now let's connect once more using Temple because I left it a little while, so it logged me out, or disconnected my wallet, I should say. So now we are connected. And then the final thing that we need to do is we need to make sure that because we want to use GhostNet, as we mentioned earlier, we update the node that our dApp is using from a mainnet node to a GhostNet node. So I'm just going to Google GhostNet Tezos nodes. And the first result is actually in the Taquito docs, which is convenient. And you'll see here it lists out a load of public nodes that we can use. So we're just going to use this GhostNet node here. The ECAD Labs nodes are very reliable. So we can just copy and paste that URL and replace here this with the GhostNet node. And then we add another parameter here, network type. Network type. I think that requires an import here if I remember rightly. Network type .ghostnet. Perfect. Okay, so now our dApp should be pointing at GhostNet because we've got a GhostNet node here and we've configured Beacon to use GhostNet. When we sign this payload, the gas fee that we will pay will be the TES that we got for free earlier by going to that faucet and not actual TES that we would need to pay money for or have acquired from someone else. So let's try running this. Back we go over to localhost 3000 /episode 4. Okay, so now let's log out of Temple because we were logged in on mainnet and now we want to log back in on GhostNet. Now I'll hit connect again. Yes. Yes. Connect on GhostNet. Perfect. You can see it's saying that we're on GhostNet here in the top right. Okay, so let's try and sign the message and see what happens. So I'm going to click sign message. So signing for my account on GhostNet, and this is the message as we requested for it to be signed, and I'm going to click sign. Successfully signed payload, and here you can see the payload signed successfully. Amazing. So I think that covers everything for this episode, and leave you with a thank you for listening to this episode. We covered quite a lot this time. And looking forward to seeing you in episode 5.